Alright guys, Brian here. We're going to do a quick coding challenge using some JavaScript. So you're standing in a long line at a market and you want to practice your math skills apparently. Because that's what we all do. You have 3 coins with values A, B, and C. You choose some of them, possibly none, but definitely not all of them, and put them in your right pocket. Now you're curious how many different amounts of money in your left pocket can theoretically be left after you do it. So in their example, they used all the same number, 1, 1, and 1, but theoretically you could have like 1, 2, and 4, for instance, or some other numbers. And you're gonna figure out how many different possible values for coins can remain in your left pocket after taking either all of them, one of them, or none of them, one of them, or two of them. Alright, so the way that I want to do this is to use the JavaScript set prototype. And so set basically creates like a mathematical set that guarantees independent values. So what it's doing basically is, for instance, if you have a set like let our set is assigned new set. That's how you declare a new set. Our set could take values like 1, 2, 3, for instance. But if you, and the way you add values is you do our set dot add and then your new value, like 4, for instance. So what it does basically is if you had a set like 1, 2, and 4, and then you tried to do our set dot add 4, dot add 4 to this set that we have here already, that will not add 4 to that set because all of the values in this set are going to be like original, or it won't have duplicate values. That's what it guarantees. So that's kind of how I'm going to solve this problem. Is we're going to just literally go through all the combinations and just add them to our set, and then at the end of it only the unique ones will be remaining. So when I first originally tried to solve this problem, I kind of wanted to do it in this way of like, I was gonna say like, well, there's 3 different possibilities here. Either A can equal B can equal C, or A can equal B, or B can equal C, or A can equal C. And then lastly, they're all unique. A not equal B, not equal C, right? So in the top one, they're all the same. In the middle one, 2 of them are the same, and then the last one, they're all different. And I just did like the case for each of that, but I didn't realize when I was doing it that that actually means you could have 2 numbers. For instance, if A was 2 and B was 3, those, and it's going to be plus C, oh, and then our set, oh, and we'll have A plus B, and then, so let me just kind of copy this structure. Our set dot add And I'll just copy this line here. Alright, so then we'll have B plus C, and then we'll have A plus C. So I'm just getting all the different unique combinations, and then what the set allows us to do is guarantee that there's no duplicates in our final list. So then we'll have A, B, and it looks like I need one more, and that's going to be C. So then with the set notation, to get the size of that, and that's what we're going to return, is going to be rset.size. So that's our answer, and we'll run the sample tests. Make sure we didn't mess up. Looks good, so we'll submit that. Alright guys, thanks so much, and I'll see you in the next video.